Today we're going to talk about absolute value inequalities. We have the absolute value of x minus 7 plus 2 is less than 12. So we've got two trains of thoughts here. We've got to worry about the absolute value equation, and we have to worry about the inequality. In order to do absolute value equations, you can't get rid of the absolute values until they're all alone. So we've got to make sure before we do anything with the absolutes, we get rid of the 2. Since 2 is being added, we're going to do the opposite and subtract it. Remember with inequalities, if you multiply or divide by a negative number, the inequality symbol flips around. So don't forget that rule as you're dealing with inequalities. All we did was subtract, so we don't have to change our sign, it's going to stay the same. One thing I see a lot of times when I'm grading tests is students will let the absolute values just disappear. Math is kind of like the real world. If something goes away, there's an effect that comes from that. There's a consequence to something just disappearing. When you make your absolute values go away, something has to happen in order for that to be mathematically correct. Many times the confusion comes with parentheses. Absolute values are not parentheses. They don't follow the same rules, they can't do the same thing. You cannot distribute throughout an absolute value, that will not work. So in order to get rid of an absolute value, you've got to have some sort of a consequence. And that consequence is the equation's going to become two equations. It's going to get broken up. So we're going to take this single equation, and when the absolute values go away, we're going to end up with two equations. So what these two equations are, one of them, all the signs are going to stay the same. So my x minus 7, my less than sign, and my positive 10. All of that is going to stay the same. On the other equation, all of my outside signs are going to change. Meaning my x minus 7 is not outside. It's going to stay exactly the same. X minus 7, less than is a sign, the less than sign. That's going to change to a greater than. And then 10, it's going to change its sign and become negative. Every time you break them out, one is the exact same equation, and then you have the negated value. And because it's the negated value, the sign, inequality sign needs to change as well. The other aspect that we have going on here is because it's an absolute value and an inequality together, we need to determine if this is an and statement or an or statement. So what you're going to do is you're going to look at the inequality sign at the moment right before you broke it up. The last time the absolute values were there, what was your inequality sign? And you need to make sure you know the name. This is a less than sign. Less than is a less than statement. So it's an and statement. If it was a greater than sign, it would have been an or statement, great or. Less than, great or. It's kind of built into there. What this means is that when we eventually get our answer, we start to get these equations finished. We're going to want where their graphs overlap is the part that we want. So if they go in opposite directions, we only want the center part where they overlap. If they go in the same direction, again, we only want the part where they overlap. So at this point, we have two different equations and we have their connecting word. We're going to take the two equations and we're just going to solve them down. I need to solve for x. 7 is being subtracted, I'm going to add it. I can add a number to both sides without changing the inequality symbol. X is less than 17. And over here, I'm going to do the same thing. I'm going to add. Because I'm adding, the inequality symbol should not change. Negative 10 plus 7 is negative 3. Be careful with your sign numbers. It's really easy to accidentally go through the motions and end up getting the wrong numbers. Okay? So this is a part where another part where a lot of people get stuck. They're like, okay, I've solved it down, but I don't know how to get my answer. And on my test, I ask students to give their answers in interval notation. The easiest way to get interval notation, in my opinion, is from a graph, because you can see it visually. A lot of our students that struggle with math are visual learners. And so to be able to get it in a visual format really helps a lot of students. So we're going to graph. We're going to have -3, and we're going to have 17. Those are my two numbers. Make sure left to right, it's in order from smallest to largest. So I'm going to take the first equation, x is less than 17. And getting that on the graph is easier said than done. A lot of people say it's going to go to the left because of the arrow, but that's not always true. It's dependent on where the variable is. If the variable is in the wrong place, then it doesn't always follow the arrow. So what we're going to do is I'm going to change this statement into words. So x is where I'm shading. So my shading is less than 17. Okay. Now if we think about this logically, if we think about this with something that makes more sense, like money. If you have less money than someone, it means you have a smaller amount of money than someone, correct? So the shading is smaller than 17. So if you can find your 17, that tells us we're going to shade the smaller numbers. Well, the smaller numbers would be towards the negatives. So our shading from the 17, I'm going to do it right above it, should go this way. Should be our shading for the 17. Now add the 17, is it actually equal? No, because it's just less than. It's not less than or equal to. If it's not equal to, you're going to use a set of parentheses. If it was equal to, you would use a bracket. So we want parentheses on the 17, and we want them to open towards the shading. So I want them to, kind of like they point. I want them to point towards the shading, open towards the shading. We do the next one in brown. We have x is greater than -3. X is your shading. Is greater than -3. So if you have a greater amount of money than someone else, that means you have a bigger amount of money. Right? So the shading is bigger than -3. Sometimes the words help it to just make it a little bit more relatable to us. If you can put it in bigger and smaller rather than less than and greater than. So if we identify our -3, that's going to be here. And we said the shading is going to be bigger, so that means it's going to go that way because it's going towards the bigger numbers. And then we need to figure out what type of symbol do we put on 3. So we go back to the equation and ask, is it equal? Just greater than, but no equal sign. So that means we're going to use parentheses and not a bracket. Again, it's going to open up towards the shading. Okay. Next thing we need to do is we need to finish with the and. A lot of people accidentally stop here. But we need to actually get this and word figured out. We haven't done anything with the green yet. So and is your overlap. If it was or, it's anywhere that's shaded on either or graph. So it would be, in this case, negative to positive infinity. But since it's an and statement, in an and statement, you only want where they overlap. So if I look at this, all of this area over here, I only have one color. And it's only the blue, so the two graphs are not overlapping. If I look at the center, I have both brown and blue. So here my two graphs are overlapping. And if I look at the far edge, I don't have blue, so my graphs aren't overlapping. So my answer is only this center portion, because that's the only place where the graphs are actively overlapping. And then you're going to take whatever symbols were on the numbers. The 3 had a parentheses on it in brown. The 17 had parentheses in blue. And then once we have the green graph, we can take that and put that into interval notation. So in green, left to right, the first thing to appear is parentheses opening. So we are going to open your parentheses. What number are they on? That's on -3. Green continues on until you get to 17. And you close parentheses because that's the symbol that was there. So your answer here is from 3 to 17. Parentheses would complete your interval notation. Okay, so just a quick recap. You cannot get rid of absolute values until they are all alone. Once they are alone, they cannot just disappear. You've got to make sure you break the two equations up. You have to make sure if it's an absolute value inequality, you identify and or. If this was an equal sign instead of an inequality, you wouldn't have to worry about the shading. You wouldn't need the and or the or, it'd just be 2 points. Since it's an inequality, we need an or, depending on which one it does. Again, less than is an and statement, greater than is an or statement. Less than, great or. Once you get your equations solved down, I suggest graphing them. It's a really good visual way to figure out what's going on. Once you get the graph, if it's and, you want the overlap. If it's or, you want anything that's shaded on either or graph. To get the shading, again, I would put it in words. I just feel like that's extremely helpful to people. So hopefully this helped you out. Thank you.